This is a solutions video for the chapter 4 through 6 test for statistics in the spring of 2014. First question is a data table, and I try to start off pretty straightforward. It's using the probability of A or B, and so we want the probability if we randomly pick someone that they are a man or heavy smoker. So if we look over here at men, there's 601 heavy smokers, looking at 89. So if we just add those up, that'd be great, except for we've counted these 49 twice, so we need to subtract them away, the intersection away, and we end up with 640 of 1156 for about 55% chance. And then the second one is find the probability that a person is a man and occasional smoker. So you can just look for that intersection of those two, and this is 50 out of 1156. On 3, what's the probability that a random selected person is a woman given she's an occasional smoker? So we want to find the ones that are both woman and occasional smoker, so that's 48. But the second thing is, given that there's occasional smokers, so we're only going to look in this column of occasional smokers, so it's 48 out of 98 right there, so about 49% chance. And then I have you do the opposite, or flip it. What's the probability of an occasional smoker given she's a woman? So it's still the same 48, but now we're looking at just the women. That's our population we're comparing to, and that's 555. So 48 out of 555. On number 2, okay, here we go. Number 2, manufacturing process has 70% yield. That means 70% are good, 30% are bad. What's the probability that you would get 3 in a row that are good? So that's good and good and good. So it's 0.7 times 0.7 times 0.7, which is 0.7 to the third, which is 0.343. And the second part, I'll go down here a little bit. What's the probability of getting 2 defective in a row? So that's defective and defective. That's 0.3 times 0.3, which is 0.09. Sorry about this. It kind of, when there's a random page break, it repeats it again, if you're wondering about that in the solutions here. On this one is 3 out of 5 exactly, so this is a binomial, so 5C3, this is all the different ways that could happen, and this is the probability of that event. So we went 3 good, 2 bad, so 0.7 to the third, 0.3 to the second, multiplied times the different ways it can happen, and we get 0.3087. On number 3, we've got 18 books. How many different arrangements of 3? So how many different ways could I give 3 books to somebody? And this means order does not matter, so it's combinations. 18C3, 816 different ways you could do that. 4, if there's 12 defective and 13 good, what's the probability of getting 2 good in a row with replacement? So it's 13 out of 15 times 13 out of 15, which is about 75% chance. Now if we don't replace, that means when we pull that good one out, now we're down 1 good one. So it's 13 out of 15, but then we multiply it times 12 out of 14, 1 less of each. And that's about 0.74, a little less probable. On number 5 here, we want to find 59% find a job within a year, and it says among 6 randomly selected graduates, at least 1. So we'd have to find 1 or 2 or 3 or 4 or 5 or 6, which would take a lot of work. So what we did here is say, all right, let's just find the probability that nobody gets a job, because it's the only other scenario, and we subtract that from 1. That's the complement. So 1 minus the opposite of at least 1 is nobody getting a job. So nobody getting a job would be 0.41 and 0.41, and so that's to the 6th power. So we got there's about a 99.5% chance that if you randomly picked 7 people, you would get at least 1 person with a job. And number 5 here, it's a probability distribution. You're just supposed to find the expected value, and that's just the sum of x times p of x. So it's just 3 times the probability of it. These are like the weighting, or what you get, probability of it happening. Multiply those, add them up, and you get 8.22 for your average value of that distribution. On 7, it's a life insurance one. A couple ways you can do this, but probably the easiest is just to figure out what's the probability that they die. So that's 1 minus the probability that they live. So the probability they die is 0.0006. What happens when they die? Well, you get a payout of $150,000, which is about a $90 payout. But it costs $181 for the policy. That means the insurance company is going to make $91 in every policy, or for the policyholder, that's a loss of $91 on average. On 8, We've got 1,000 lottery tickets, so we essentially find the expected value, or what's the average. So the probability of winning is 1 out of 1,000. What do you get when you win? You get 500 bucks. So the average payout is 50 cents, but it costs $1 to play, so on average, everybody's losing 50 cents. So it's like a 50-50 raffle, which is honestly pretty close to the real lottery. It's about a 50-50, what they pay out compared to what it costs to play, expected value. On 9, they will accept the entire batch here if it has 0 or 1 defect. If it's got to have fewer than 2. So we just find the probability of 0, and here that is, and here's the probability of 1, and we just add those. So here's the probability of 0 is 0.3235, probability of getting exactly 1 that's bad is 0.3746. So combined, that's about a 0.6982% chance that they will accept the entire shipment. That's because that's the probability you get 0 or 1 defect. All the other ones would have 2 or more. 10, just a normal distribution problem here. Make sure you draw the picture, average in the middle. Essentially, what's the probability that if the average is 60, you get a 53 or lower, and you get that's a negative 1.75, and if you look up in your z table, that's 0.041 or 401. On 11 here, we want to find the area between, so I guess I should have shaded that, I'm sorry. It should be shaded between right here. And so we find the two z-scores. So the z-score for the upper gives you a z-score of 0.58, and if you look that up, that's a 0.719. So that's the area below 140.1, about 72% almost. Then we do the other one, find what's the area below 134, and that's a negative 0.49 standard deviation. So we find that p-value is 0.4132. Then we subtract those. So we take the area below minus the area below, gives us the area between. So that's 0.4069. On 12, they want to find the score for the top 9%, which is the same thing as the 91% is below. If you look up 0.91 in your z-table, you get 1.34 for the z-score, and we don't know what test score that is. And the average is 37, standard deviation is 7.5. So we multiply both sides times 7.5, and then we end up adding 37, so 47.05 would put you in the 91st percentile. On 13, this is the first part's pretty straightforward. Find the z-score of a 29 if the average is 22. No problem. It's 1.21 standard deviations above the mean. But now they want to know what's the equivalent on this exam. So we don't know that score, but we do know the z-score has to be the same. So we're going to use this 1.21 again. We don't know the score of the test. We do know the average and the standard deviation. So we solve this for x the same way we did the last one. Multiply by 10.6, add 72. So we get 84.83 is an equivalent to, on this test, is the same thing as a 29 on that exam. It's the same percentile rank or same z-score way. 14, this is snowfall. Find the area above. So we find a z-score of 0.28. And if you look that up, that's 0.61. That's below. But we want to find the area to the right, so we subtract that from 1, and we get 0.3897 to the right. And that says, what's the probability of the average for 25 years? So this is an essential limit theorem problem. So we find the difference, but the standard deviation is much smaller now. So we get 1.4. Look up that. That's 0.9192. Again, subtract from 1. That gives us to the area to the right. It's about an 8% chance. So much less probable that the group mean for 25 years would be above that. 15, there's a test of average of 83, standard deviation. Just pretty straightforward. Find the area to the right. Again, 1 minus, and if we look up negative 0.63 on our z-table, we get 0.2643 below. That means the area to the right is 0.7357. And then if we want to find the average, so now that's the probability of getting one student above a 78. Now what's the probability that the class average is above 78? And if we look that up, that's going to be, we have to divide by the square root of 16, and we get negative 2.5 standard deviation, same picture, but much larger percentage chance that that would happen, because if you look up negative 2.5, that's only 0.0069, subtract that from 1, so the area to the right there is 0.9938. So pretty certain that the class average would be above 78 in this case. And that's it, and there are 63 points. So hope this solutions video helps you get ready for the final or the test for next semester.